Hey, Hugh here. I'm going to teach you a little something about physical and chemical changes. First chemical change I'm going to show you, it's called rust, but usually it takes a couple days. We're going to do it in a couple hours. We don't have that much time on our hands. So, first thing I got here for you here is some steel wool. Steel wool contains iron and carbon. When you put steel wool in water, this creates rust. Why? Because iron and oxygen, that reaction when those two meet, that corrodes steel and therefore creates the rust. So, now I'm just going to take you through all the materials that we got here. Everything on the table is going to be used for the experiment. So, first thing, water. H2O, liquid substance, use it to drink, wash off, whatever you want to do. Look, I'll take a sip of it right now. Okay, so that's water. Good for you, good for everything. So, here we got some vinegar. The vinegar is going to remove the protective coating on the steel. Vinegar, household product used for cooking, whatever. Smell it. It's good stuff. What we're actually putting in the water, you see, steel wool, this stuff right here. Up, down, around, whatever. Yeah. Next thing, metal bowl. We're gonna put everything in here. Other uses, cooking. It can be used as a hat. You know how many friends I made doing this? Would I go into a war zone using this as a helmet? Do bears crap in the woods? Next thing, Red Bull, not actually going to be used in the experiment, but had a long night last night just trying to get amped up, kid. I love chemistry! Last material, we got some Clorox bleach. Bleach is just going to add oxygen atoms into the reaction to speed up the process. And now we mix. Also got some matches. Spoiler alert. So now we're going to start the process. Here's the water. Pour this thing in. 8 cups a day, kids. 8 cups. That looks about good. Alright, next we're going to move into the steel wool. Just going to dash this in there. Let it go to the bottom. Should be good now. Vinegar. Should be enough. That is stinky. That is not good. And last we're gonna go with the bleach. And that should be it. And now we wait. So, as we wait, we're just going to show you some other chemical changes and physical changes. But first off, matches, chemical change. They can be used for anything.
Like lighting a small candle.
Somebody call 911. Shawty fire burning on the dance floor. Whoa. What's up, one?
Or even melting some chocolate.
If you are wise, you'll listen to me. What do you get when you guzzle down sweets? Eating as much as an elephant eats. What are you at? Getting terribly fat. What do you think will come of that?
Or even lighting a small fire.
Girl, we couldn't get much higher. Come on, baby, light my fire. Come on, baby, light my fire. Try to set the night out on fire. Time to hesitate is through. No time to wallow in the mire. Try now, we can only.
Here are some physical changes.
As you just saw my co-producer down at the beach, he collected this for me, a little bottle of salt water. So we're just going to boil some salt water to see the salt residue that's left behind.
So as you can see, he's just pouring the water in there right now. We're going to put this thing on high, let it boil, find the residue behind. Turn this thing all the way up here, all the way on high, Here we go. Oh, look at all that salt. You don't eat that salt, don't you do it. Oh, he did it. So now we go back to the steel wool experiment. Here my assistant is just pouring out whatever's left of there. You can see the rust kind of start to come out in the liquid as well. He's going to pull out the steel for you in a minute, and we're going to zoom in and see how bad this thing actually rusted. It is only about an hour and a half, so let's see what happened. Oh yeah, oh yeah, thing's filled with rust. Great chemical reaction, just a great chemical one. There it is, oh yeah.
And now on to the classic 6th grade middle school, whatever you want to call it, chemistry project. Baking soda plus vinegar in a volcano, except we don't have the volcano.
What actually happens is this: the acetic acid reacts with sodium bicarbonate to form carbonic acid. It's really a double replacement reaction. Carbonic acid is unstable and immediately falls apart into carbon dioxide and water. The bubbles you see from this reaction come from the carbon dioxide escaping the solution that is left. Carbon dioxide is heavier than air, so it flows almost like water when it overflows the container. What's left is a dilute solution of sodium acetate in the water.
And now to show you some physical changes. I'd go into more detail, but they're kind of simple.
Yep.
There's so many of these friggin' things, I can't even count them on one hand. I can't even count them on two hands. Ice to water, water to ice, gas to water, gas to ice. I'm gonna show you what it looks like to throw a banana at a fence, people, okay? I've already shown you a couple. Remember what that can used to look like? Yeah, that good.
And she's on fire, hotter than a fantasy, lonely like a highway. She's living in a world and it's on fire. Filled with
Right here, we got some melting salt and some ice. This is the chemical way to melt some ice.
You cursed rat! Look what you've done! I'm melting! Melting! Oh, what a world! What a world! Who would have thought a good little girl like you could destroy my beautiful wickedness? Ah, the mouse! The mouse! I'm going!
So you watch this video, you do good on your test, you learn good chemistry, you get good grades, you do good on your test, you get A's, you do good on your test. Chemistry.
Everybody in the car, so come on, let's ride to the liquor store around the corner. The boys say they want some gin and juice.